Let's talk about induction stoves on Green Neighbor. Well, all right, this is our induction stove. We've had it about 12 years. It's a Samsung. We quite like it. It's worked very well for us. But what I want to demonstrate for you right now is how quickly this stove will bring 1 cup of water to a rolling boil. So you'll see I've set this up so that you can see the tap right here and you can see the pot right here. I won't cut the film until after that water comes to a rolling boil. I also have a GoPro up here recording the action from the top so you can see for yourself when the water starts to boil. Let me get 1 cup of water into this measuring cup, and I'm going to put just a little bit more than a cup so that there won't be any question about whether I did indeed bring 1 cup of water to a boil. So you can see there we've got 1 cup. I will just put that into this pot. Now with this range, what you do is first you turn on the stovetop, then you select the element that you want to turn on, and then I'm going to use the maximum power in this element, which is called Power Boost. Here we go. The timer starts now. I'm going to put a lid on. That will obviously boil much faster with the lid on it, but I'll take it off to show you that it is indeed coming to a rolling boil. So what you'll see here is this should take about a minute, maybe even a little less, for this 1 cup of water to come to a boil. Now that is about 1/3 of the time required for a gas range to bring a cup of water to a boil. Gas ranges are known to be very fast. And you can alter the temperature either up or down very quickly because it's fire. And if you hold your finger above a flame, it is instantly hot. It doesn't take a flame time to get hot. All right, we can see this is starting to boil. I don't think it's come to a full rolling boil yet, but let's take a look. It will soon. All right, and there it's come to a full rolling boil, so we'll stop the clock there. Now, I want to show you something else here. Look how quickly this water stops boiling when we turn the power off. You can't do that with a traditional glass top stove because typically what stoves do is they heat up the element and then the heat from the element transfers through to the pot. So if you turn the element off, the element is still quite hot, and that heat is still transferring through to the pot. In this case, an induction stove does not actually heat the element up. It heats the pot up by vibrating the atoms in the metal of the pot. And that's why you have to be very careful about what kind of cookware you use on an induction stove. Some pots won't work. I'll show you how you can determine what cookware will work on an induction stove later on in the video. Something else I'm going to show you is if I were to turn this back on and boil that water again, you'll see that even after this water has come to a boil, so the element's obviously working as hard as it can. It's boiling that water in just a few seconds. Now we turn it off, remove the pot, and I can actually touch that element. I wouldn't want to leave my hand there. It's quite hot, but it's not nearly as hot as a conventional glass top stove. Because again, this stove doesn't work by heating the element, it heats the pot. And it's actually the pot that's getting the element hot. So what's great about that is I could spill some water, something could spill over, and we can just wipe it up immediately. And you couldn't do that with a conventional glass top stove. I've learned that lesson the hard way. What happens is the fabric that you're using will melt right to the stove top. And when it happened to me, I could never figure out a way to get that material out of the stove top. It basically bonded right with it. Another thing that I really like to do with that warm element is after I've cooked something, I like to put a plate on top of it while I'm serving the food out. That warms up the plate, but it's not so hot that it's going to crack the plate. And so it works very well as a plate warmer while you're serving out food, and then that keeps the food warm. All right, so let's talk a bit more about induction stoves, why they're more efficient, how they work, what kind of cookware works with them, and why they're better for the environment.
So right off the bat, both induction stoves and conventional glass-top stoves use electricity as opposed to natural gas, which, by the way, is just a fancy marketing term for methane. Unfortunately, the extraction, refining, and distribution of natural gas literally generates tons of leakages. The U.S. Environmental Protection Agency estimates that about 8 million metric tons of methane leak from the oil and gas supply chain each year. The Environmental Defense Fund says that number is closer to 13 million metric tons. Wasted gas that is enough to fuel 10 million homes a year. Beyond that, every time a burner or the oven of a gas range is turned on, it produces carbon dioxide, another powerful greenhouse gas. A 2022 Stanford study estimated that gas stoves in the U.S. emit 6.2 million metric tons of CO2 each year, equivalent to the climate impact of over 1 million gas-powered cars. Now, an induction stove actually provides a similar cooking experience to a gas stove, but without all that methane and CO2. It's all about how quickly you can create and adjust heat in the pan. Induction cooking is both quick and efficient because it uses a process called electromagnetic induction to directly heat a pot or pan, as opposed to a standard glass or ceramic cooktop, which heats the cooktop itself and then relies on that heat to radiate up through to the pot. Here's how an induction stove works. Beneath the surface of an induction cooktop, there is a copper coil. When you turn on the cooktop, an alternating current is passed through the coil. The flow of AC electricity through the coil generates a rapidly alternating magnetic field around it. This magnetic field extends above the cooktop surface. When you place a compatible pot or pan on the induction cooktop, the rapidly changing magnetic field induces small electric currents, known as eddy currents, within the cookware. These eddy currents encounter resistance from the iron molecules in the cookware's base, and as a result, they stimulate the iron molecules in the cookware, causing them to vibrate more than 10,000 times a second, rub against each other, and create friction. The friction from all that rubbing causes heat in the pot itself, while allowing the cooktop to stay relatively cool. Now, for induction cooking to work, you need to use cookware that has a magnetic bottom, such as cast iron, stainless steel, and even specially made non-stick pans will work. Non-magnetic materials like aluminum or copper won't work unless they have a magnetic layer on the bottom. You can tell if cookware will work with an induction stove by either looking for this symbol in the store or by testing it with a magnet. If a magnet will stick to the bottom of the pan, then it will work with an induction stove. In summary, induction cooktops offer several advantages. They are highly energy efficient because the heat is generated directly in the cookware, and there is minimal heat loss to the surrounding environment. While the open flame of a gas range provides instant heat and immediate response, it is by nature quite inefficient because you really can't control where that heat goes. Energy Star states that almost 70% of the energy from a gas range just flows out into the kitchen. Induction ranges were found to be the most efficient option, with an energy efficiency rating of approximately 85%. Induction cooktops provide precise temperature control and rapid heating and cooling, making it easier to cook delicate dishes or simmer at low temperatures. Induction cooktops do not produce an open flame or radiant heat, and the cooking surface remains relatively cool to the touch. They can also offer features such as automatic shutoff when no cookware is detected. Since the cooktop surface doesn't get very hot, spills are less likely to burn onto the surface, making cleanup a lot easier. If you are currently cooking with a gas stove and you're looking for a safe, efficient way to reduce your household emissions, an induction stove is a great option to explore. To get more tangible ideas on how to lower your carbon footprint, please visit the Green Neighbor website at www.green-neighbor.com. And I'll point out that neighbor is spelled the Canadian way. If you have any questions, thoughts, or ideas, please drop me a line over email or social media. You can find me on Twitter, Instagram, and LinkedIn. If you'd like to learn how to make hair grow on a doorknob, don't click on this video here, because it's got nothing to do with that.